those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. Okay, here we go, guys. I apologize for the delays, but I promise you all this is going to be worth it because we've got Professor McQueen back with us today for a very, very important show on dating methods and evidence for accelerated nuclear decay. Real quick, though, we've got a couple reminders. Okay, we've got Michael Ord tomorrow with us, which I am extremely excited for at 4 o'clock EST. He's going to be here for a presentation on the flood and a discussion on the flood as well. So a question and answer period from the audience. So make sure you are here for that one. As well as next week, we have a big debate. It's the rematch between Kent Hovind and Jordan, a nuclear engineer from Reasons to Doubt podcast. They are going to be debating the age of the Earth. So that's going to be an exciting one. Anyways, enough for me. Just wanted to go over those couple reminders, and we are going to bring in the stars of the show. Stars of the show being George and Professor McQueen. As always, gentlemen, it is a pleasure, and thank you so much for being here.
Means a great deal to me, Standing for Truth. Thank you for the new format.
No problem. And we've got some new jokes too, don't we, David?
We do, my friend.
Hey, George, no show with you would be complete without a few jokes. So,
yeah, well, I'll introduce the audience to one. What do you call a famous geologist like Professor McQueen?
A rock star.
A rock star.
Very good. Very good.
All right, let's get on with the show.
Okay, we'll get on with the show. As we've done in the past, we're going to divide this into basically 30-minute segments over the next couple of hours. I'm going to note the time and give an introduction to these two things during the first 30 minutes. The concept of halos, which deals with the decay rate, catastrophic plate tectonics, accelerated radioactive decay. So we'll go over those topics, give a 15-minute introduction to both of those, and then allow the audience to begin to stream in to Standing for Truth the questions that this will bring up, which it certainly will bring up questions. And we'll challenge George on his engineering knowledge of calculus and other things. So we're going to take you where some people don't want to go back to. There's some people that don't want to go back to college calculus. I assume as an engineer, you had to suffer through several at the university.
Oh, yeah. But this will be interesting because it's been over 45 years for me.
And I took my first calculus 2 years worth around 50 years ago. So it'll be a good review. So let's go ahead and get started. I want to encourage you to go online and look up R.V. Gentry. Here's the correct spelling of his name. In 1973, I met Dr. Gentry in Knoxville, Tennessee. We had a discussion group. I had only been married 1 year in 1973, and I took a break from my honeymoon to go to a discussion group about creationism, creation evolution, and Bob Gentry was there. He learned that I was finishing up my undergraduate degree in geology during that time, and our friendship grew. And he hired me as a part-time laboratory assistant for him at the famous nuclear facility, ties into World War II history, called Oak Ridge National Labs. Oak Ridge National Labs was a premier nuclear research facility from back in the 40s. Well, by the time the 70s had arrived, Professor Gentry, Dr. Gentry, had been working for a college on the East Coast of America. And the college struck a deal with the leadership of Oak Ridge National Labs so that Dr. Gentry could go there for a salary of $1 a year. The rest of his salary would be paid by the university to do research on what are called radioactive halos. Now, as a geologist, I have to teach George so many things, like I can show him a granite and I can say, don't take it for granted, George. You find that humorous, I'm sure. And so we have to learn some new vocabulary. Pleochroic halos are the same thing as radioactive halos. Now, where does the word pleochroic come in? The halos that form the evidence for one of the major critiques of radiometric dating come from micas and fluorites, but we're going to emphasize micas for right now, in granitic rocks. Now, George, here's a geology lesson from Geology 101. Here's a bound notebook of paper, and you can see the different pages. And so if we had mica, as could be found in areas there in Australia and in the Appalachians of the United States, this would be called a book of mica. And so each individual sheet of mica could be exposed, and you can tear it off like this from the book of mica, and it's a sheet. Interesting part of American history that my wife has taught me, as in pioneer America, if you had a clear mica called a muscovite, they would tear off big sheets of it, and it was given the European or German word isinglass, and they would actually make windows of this. I don't know if you've ever heard that in the use of mica for a window. A lot of people don't know that detail, George.
I knew mica were you could separate them in sheets, but I didn't know what the use of them were. But that's interesting. Yeah.
Yeah, it's an interesting detail. So when I worked for Bob Gentry at Oak Ridge National Labs, he would have underneath the microscope a specimen that he had of mica. And my job was to, using a small Q-tip and some grit, I would begin to tear off those sheets of mica, looking for something that turned out to be very important. And let me use my models here to illustrate this for you. If you look at mica, often you will find inside the mica a small grain of a mineral called zircon. Now, George, again, here's some mineralogy for you. Zircon is zirconium silicate, but the atomic structure of zircon is such that uranium, and I'm not saying the word plutonium, I'm saying the word polonium, that's PO on the periodic chart. Those elements, along with thorium and others, can substitute in the part of the crystal structure where the zircon is. And so inside of these micas, I was looking for the zircon caught in the middle of the matrix. And because of some physics we're going to work through, everybody get out their differential equation books, because you'll need those in a minute. Because of what Gentry was doing, it was very important that when I was doing my work, that I did not measure the radius of these halos like this. You'll notice that I've not cut a what we call a section through the diameter, but can you see that would give a radius that would be incorrect? let me use another styrofoam model. I'm here in the sewing nook of my dear wife. So she's allowed me to borrow what I hope you see is a red pin there. And if I put this together, I would work and work and work, take hours to do it, to sand down these zircon crystals so that I could see the exact diametral section. So, George, is the geometry of this clear so far?
Oh yeah, definitely, yeah.
So we're going down and we're trying to get a section that looks like that. Now, the reason that we were doing that, and I would recommend this book for you if you have not already bought it. This is Bob Gentry's book called Creation's Tiny Mystery. And here you see what's called a polonium halo. And George, do I have it close enough that you can see that there are 1, 2, 3 rings there?
Yes, very clear. Yep, clear.
Particular polonium halo.
Yep.
And then if you look at what I looked at 50 years ago, you can see some of them have only 1 ring, some 2, and some 3 as I scan down here. Now, why in the world would that be important? And how does that tie in to one of the major critiques of radiometric dating? Well, it ties in this way. Or rather, going back to 1960, there have always been 3 basic criticisms of all radiometric dating techniques, whether it's uranium lead, potassium argon, rubidium strontium, it doesn't matter. There have always been 3 basic critiques. First is, how do you know that the radioactive decay rate, the half-life, has been the same through billions of years of geologic time? Or using the Grand Canyon as an example, how do you know it's true from, say, the Cambrian up through modern times? Or let's go back a billion years into the Precambrian. Okay, that's the first thing. How do you know that the decay rate is constant? The second thing is, how can you know the original amount of uranium in the rock? That's called the parent isotope. And then the third argument has been, again, since 1960, how can you know that no geologic process added or subtracted? I'm going to use this later. Bob Gentry has come up with a number of ways in which he explains what a radioactive halo is. But one way that he does it can tie into my example here. Let me make sure I don't spill this on Mrs. McQueen's floor. But here I'm pouring water into this glass. And if you have hot, salty water moving through the rocks, that's going to cause chemical reactions, which we will add to or subtract from the amount of radioactivity in the rock. And so those are the 3 basic critiques of radiometric dating. So let's focus down on Gentry's work and see why is that important. His work starts with some work on pleochroic halos. That is a zone of discoloration that's routinely found in biotite micas. And when I was a student at the University of Michigan in the mid-70s, there was a German mineralogist, first generation actually in America, E. William Heinrich, very well-known uranium geologist. And I asked him one day, could you show me in your lab some pleochroic halos that you've found over the years? And sure enough, in Germanic fashion, he pulled out a drawer and showed me some mica that he had thin section done on. And sure enough, when I looked down the scope, I could see the rings through the microscope of the mica. Now, why was it such a big deal to Bob Gentry that I measure, there's the zircon in the middle of this mica. Why was it so important for him that I measure this section instead of making a mistake and doing a section that did not go through the middle. Many of you probably do differential equations right before dessert as you eat a meal. Do you do that, George? I don't often do that. But let's imagine what's going on in radioactive decay. What Bob Gentry would often do is he would take an Alka-Seltzer. Is Alka-Seltzer sold in Australia? Maybe you've got a different kind of antacid there. But you know, plop, plop, fizz, fizz, you know what I'm talking about?
Oh, yeah, you can get it here.
Yeah, so he would drop that into a glass of water, and as it fizzed, it would expand, and that would be his way of diagramming or helping people understand the radiation damage done by alpha particles as the uranium and polonium decayed. Let me find my specimen here. Inside this zircon, you've got radioactive elements that are decaying, and they're shooting off alpha particles. And those alpha particles, if you imagine here, I've got a tennis ball and then nested bowls taken from Ms. McQueen's kitchen. George and I use the aluminum foil to make sure that the aliens can't change our minds. So sometimes George and I wear this, but you can imagine these nested bowls as being different energy levels. So if you've got uranium here, it's going to shoot out a number of rings. So you want to have 3 rings. You got a bunch of rings, and each one of those rings is an alpha decay, indicating the decay of thorium and all the elements that are in the radioactive decay chain of uranium. So perhaps these nested bowls here will help you to see things. And so now we go to the very important differential equations. And these are taken from a paper that Bob Gentry back in the day asked me to edit for him. I didn't know much of what I was doing, but it was a paper that came out in Science in 1974. And it was called Radio Halos in a Radio Chronological and Cosmological Perspective. Now, you can look this up in Science Magazine, volume 184, page 62, or you can buy this book and it's reprinted in here. And so what was Gentry's argument about these halos? Gentry actually was a part-time calculus teacher at the University of Tennessee during his day. And so this kind of stuff was straightforward for him. Go ahead and get out your sheet of paper there, George, and let's do our homework here. Here is the differential equation, which explains alpha decay. And so write these down. The differential of lambda over lambda is approximately equal to 3/2 ZR to the 1/2 dr over r. And then you've got to add to that, George, 2z divided by e to the 1/2, and you got the partial of e over e. Now, I'm sure that many of you in the standing of truth argument, or audience rather, have all this memorized, but let me help you with it. The z in this equation is the atomic number of the atom in question. You'll recall that uranium has 1 atomic number, thorium another, polonium, PO, another. The R is the nuclear radius, the actual radius of the nucleus, which you can measure. The E is the alpha decay energy. So imagine that George and I are standing in the zircon atom right where that uranium is blasting off. So imagine that I have got a BB gun, a low velocity weapon, and George has got a deer rifle. As we both shoot from there, how is it going to pierce? Will my BB gun pierce more or less than George's rifle? what would you say, George?
My rifle, definitely.
It's going to go out further. And so
Yeah.
when it goes out further, it's going to damage the mica. Now, lambda here is the half-life. So there's differential equation 1 from Gentry's book. And here is the one. I don't know about you, George, but I get excited when I see this equation because it's so important. The differential of lambda over lambda is approximately equal to 43 dr over r plus 46 d lowercase r over r. Well, r is the nuclear radius that we talked about a moment ago, but the other r is the radius of the halo. Are you getting excited already? Well, let's try to simplify it one more step here and look at this equation. Lambda is the half-life of, say, uranium-238. And you see that symbol there? That's called is proportional. You remember that from math in the old days, George?
I do, yep.
Okay. So the half-life of uranium-238 is proportional to the radius of the element. So now the excitement builds. Now you can see why he was having me measure this. But here's the climax of this play. The climax of the play is that in the microscope ocular, you could measure this diameter. So you could actually measure the radius, rather, from the center here to the out. And were the assumption of constant radioactive decay true, then you would find in samples from the Precambrian, the Cambrian, other igneous bodies up in the rock record, you should be able to find that no matter where you went, the radius of, for example, the decay of uranium-238 would be the same. But what Gentry proved in this paper, in this book, is that the radius is not constant. As a matter of fact, the radius is so variable statistically that you actually can't say anything about the constancy of radioactive decay through geologic time. Now, I don't know about you standing for truth, but that's an exciting bit of information, isn't it?
Absolutely. Absolutely. That really destroys the assumptions behind these decay methods. And if nuclear decay was accelerated during the time of the flood, well, then those dates derived from these methods could never really be relied upon.
Exactly. Now, with your permission, standing for truth, I'd like to go ahead and entertain a few questions. As usual, we'll start with George, because I'm sure this has brought some things to his mind. And then after the question time, which we'll let go up to the end of my first hour when I take a break, when we come back from the break, we'll talk about the chart behind me about the nature of the Earth's interior and plate tectonics and accelerated radioactive decay. George, what comments do you have based on what we just talked about?
Well, for the audience, because I don't think they know exactly how big these halos are. Can you tell them, like, in terms of a radius?
Oh, yes.
In terms of measurement, because they might think it's maybe a millimeter or 10 millimeters.
Right.
Yeah.
So here is an ordinary school pencil. And if you imagine this to be 1 millimeter in thickness, which is the thickness of a coin in most countries, a U.S. dime or a U.S. penny. And then you divide that into what are called units of hundreds, thousands, 10,000s. Subdivide it, you get to a unit called a micron, which is a very small unit. And so the diameter of these halos has to be measured through a microscope because you can't do it with a ruler. Too small.
Yes, very good. Yeah. One of the ways I tackle the heat problem, David, is because I've had discussions with Dr. Baumgardner and Dr. Safadi through emails.
Yes.
We all recognize that fission is the expulsion of heat. And I'll use an example, the H-bomb. You drop a H-bomb, you get a lot of heat.
Right.
However, with fusion, and we're talking about, say, past iron, we know from experiments that the process is adiabatic. That is, the heat is absorbed, not expelled. So I know. Yeah, sorry.
The reason what George is saying is true, is not only true but important, is do you see that there is a part of the differential equation is dE? Well, that E is the alpha decay energy in millions of electron volts. And so when you're talking about alpha particles being blasted off, it's like George says, it's the difference between fission and fusion. And so you can see in this equation, if I can get my hand in the right part, that the energy is very great. So one of the areas that creation science and accelerated radioactive decay has been criticized in is, okay, you creationists, okay, you guys that believe Genesis, tell me about the E in this equation. Tell me, you got all this radioactive heat being generated. How is it dissipated?
If I could make a point there on that one, Professor McQueen, just to add a little bit to what you gentlemen are saying in regards to Jordan's question. From my understanding, he's a nuclear engineer. He's been on the channel for numerous debates.
Hello,
nice
Jordan.
Guy, great guy. We've got him debating Dr. Dino next week on the age of the Earth, so that should be fun. But I'd like to add this. We had Dr. Jason Lyle on maybe a month ago, and he made a couple really good points to this. He pointed out that, for one, we need heat to start the flood. And so the heat is not a bug, it's actually a feature of the flood, right? To get the plate moving, that's exactly what we need, is heat and energy.
And you can see the plates behind me here. In order for these plates to move and subduct, you got to get them moving. You got to get them moving.
You got to get them moving. And another thing that he pointed out is we don't actually know for certain what the temperature of the core of the Earth was in the pre-flood world. So what if much of that energy is still in the core right now?
Here's a diagram showing the core of the Earth, the inner core, the outer core. But let me respond to Brother Jordan's comment here. What mechanism would you propose to alter the decay rate? Now, I speak as a geologist. I speak as one of Bob Gentry's disciples. He never concerned himself with how the decay rate was changed. His argument was much more simplistic. The evidence from the polonium halos, uranium halos, in the micas and the fluorites provided objective scientific evidence that they had changed. He deferred to other people to do the research, and Russ Humphreys and Baumgartner and Andrew Snelling have done that research, and we'll talk about that after the break. But as a geologist, what's most important to me is when I would ask my coworkers, when I was 20, these were 50-year-old men that had been through college pre-World War II. And then I went to college myself and asked those. They would always say, "Oh, McQueen, what the mineralogists call pleochroic halos or radioactive halos, oh, that's our evidence that the radioactive decay rate has remained constant through time, because you find these in Precambrian granites, in pegmatites in the Cambrian, and so forth." And so as a geologist, and I'll comment to I see you've got another one here, that's what's important. By the way, I noticed this rue from the dot here. At what college has Professor McQueen taught if he isn't still teaching? Let me go into that because many of my critics say, well, you're a liar, McQueen, because you're a retired government geologist now, and you're an adjunct professor at a small Louisiana school. What about the rest of your resume? Well, 40 years ago, when Mount St. Helens exploded, I was a part-time professor at George Mason University in Northern Virginia near D.C. I then went on to get a job teaching at Virginia State University, which is in Petersburg, Virginia. And I was there for a year until I lost my job because of my participation in the Arkansas Creation Evolution trial. And that's part of a previous discussion. Since then, I've taught at East Tennessee State University in their physics department, National University in California. I was part of ICR's graduate school. And so that's a part of my academic background. And I might add that technically, since I'm not employed at this moment, I'm a former professor. But many people, because they know that I was denied my PhD at Michigan, show me the courtesy of calling me professor, just so they don't have to say, as they do in Australia, George, hey, you, or hey, Roo, come over here.
David, so some of these questions, you've probably heard me before. I call them shooting yourself in the foot question. And I'll take you through a bit of a scenario, right? According to the secular explanation, the Earth was a molten ball of rock. Okay?
Yeah.
Now, the radioactive elements should have existed back in those days when it was a molten ball of rock. Now, what does heat do to the radio halos?
Okay, that's a very interesting question. Now, it should come as no surprise to the Standing for Truth. By the way, good to see a graduate of George Mason University. You probably wasn't even born in 1980, so I'm quite sure I didn't teach you evidence and reasons. But at any rate, thank you for that comment. Back to George's point about the issue of heat. Many of the critics of Gentry's work, of which there are many, some of whom I've corresponded with in the last 2 weeks, argue that Gentry, being a physicist, did not properly appreciate what a geologist calls the provenance. Now, Standing for Truth, maybe you're interested in antiques. And so, one of the things that on Antique Roadshow, they're always trying to document is the provenance. In other words, this particular chair, was it really built by George Washington? And how come it's got a stamp made in Australia on the back of it? They always looking for that kind of evidence called provenance. Well, one of the criticisms of Gentry is that some of the micas and the fluorites that he collected worldwide, he traveled to Europe, to Russia, and he collected samples from very famous mineralogical localities like Wulsendorf in Europe. Many of his critics say, well, he was collecting pegmatites. He was collecting rocks that had a high heat signature. The uranium that might have been in a halo such as this, well, that uranium escaped through a crack in the rock and you don't see it. And so if the younger members of our audience that are still in university or still young enough to spend 10 years looking at this, if you go back and look at the literature revolving around Bob Gentry and also the reinterpretation that Andrew Snelling did in his 2-volume book, Snelling treats Bob Gentry with dignity and respect, but he respectfully disagrees. He doesn't think, as Gentry believed when he wrote that book, that the polonium halos are evidence of the rapid cooling of granitic bodies during the first and the third day of creation. Catastrophic plate tectonics imagines that some of these rock units were heated up during the flood, made into a mobile granite-rich liquid, which was actually intruded, according to Andrew Snelling's field work, into sedimentary rocks at a locality out west in the United States and a locality in Australia.
I would
Did
like to
that
add
help?
real quick. Oh,
Yes.
I apologize. Well, I was just going to say just one last thing I wanted to say on the heat problem for people in the audience where there are technical answers out there. For example, we've had Brian Nickel on here for over an hour discussing some of the more technical aspects of it. But a real simple answer that I like to point out is the fact that as long as most of the heat, Professor McQueen, is taken up in space through a variety of means. And one example I really like is through hypercanes during the flood, which are just really massive hurricanes, because we know hurricanes are really, really good at dumping heat into space. So at the time of the flood, these hypercanes would have done an amazing job dumping much of the heat into space. So as long as we get it into space,
Yes.
then there really is, no problem at that point.
Standing for truth, I'd like to defer a discussion of fission tracks to another day, but I will respond to what you just said.
Yes.
As we encourage our audience to seek truth about plate tectonics that we're going to return to here in a bit, and also the nature of the heat in the Earth's core and mantle and crust, this is a very real research opportunity because, as I pointed out before, if you look at the atmosphere and you deal with the second day of creation, where you're talking about the waters above the firmament and the waters below, everybody from Russ Humphrey to Dr. Henry Morris have commented about what that water was. Was it a vapor canopy? Was it a canopy of liquid, a canopy of what some scientists think might have been a metal, hydrogen, metal? These are topics for further research. The way the information stands now with Dr. Larry Vardaman's work on atmospheric physics in the Garden of Eden, it's so bad that Eve's water would have boiled in the golden bowl that Adam made for her at the Earth's surface. So that can't be true. You can't have temperatures of 100 degrees C in the garden. So that's a problem. But also how you dissipate the volcanic heat, and especially when you layer on top of that accelerated radioactive decay, as we're going to use as a theme for the last part of our discussion. When you put that in, you've got a tremendous amount of heat going into the ocean. Now, I have some ideas that I'll share about where that heat might have gone in the formation of limestones, for example. As you pointed out, standing for truth, others imagine that heat going to the interface of the water. I'll use my glass of water here. Try not to spill it on my computer. See where you can see it best. They imagine that heat coming up from the crust through the ocean of Noah's Day and then resulting in tornadic activity in the atmosphere. Interesting thought, isn't it, George?
Yes, David, there was another part of what I said before. With the secular explanation of the Earth being a molten rock, and we know that uranium and such elements are heavier elements. Yes. I mean, if we're talking hundreds of millions of years for the Earth to cool, yes. I believe it's something like 500 million years. Wouldn't you expect those heavier elements to, one, either sink down in towards the core, and secondly, why is it that we find, I believe it's something like 75 or 90% of the radioactive elements on the dry landmass.
Yeah.
How do they explain that?
Well,
I believe Krauss has called it an anomaly.
Well, let me point out to the audience what I think of as my Standing for Truth class. Is that a fair way to say it, Standing for Truth? We're like in a class here, aren't we?
That's
Yeah.
right. I think
Kind
that's
of in a class. So the way I would explain that to the class is this. When you look at the model of the origin of the Earth from an evolutionary standpoint, the problems that George is talking about is a problem that goes back to the very beginning of what geologists would call the Precambrian period. These are rocks that are 1 billion years old. We'll use that as a tag, or maybe 2 billion years old. There's some rocks in Greenland that are proposed to be 4 billion years old, and certainly lunar rocks that are that measure 4 billion years, 4.5 billion. So if you go back to the origin of the solar system, that becomes a unique mix of 3 different areas: geology, geochemistry, and actually astronomy. And that's something that we need to understand, that we have more research that needs to be done about it. But as George has pointed out, when you look at the answers that Russ Humphreys has come up with, the answers that Dr. Andrew Snelling, Dr. Steve Austin, Dr. Henry Morris, going back to his day, there are some reasonable explanations for where this heat goes. And to move my chart around a little bit behind me here, you see if I can put my thumb on it. Here is a diagram showing a subduction zone with part of the crust going down into the upper mantle. It takes a tremendous amount of heat, a tremendous amount of energy to do that. There was a scientist in the period around 1980 named Paul Lohmann, who worked at a research lab in Maryland. He wrote a paper called Continental Separation Without Continental Drift. So what in the world did Lohmann mean by that? He actually proposed evidence for how the continents separated during the time of the Great Flood. And you can't see everything on my map above me here, but if I get my finger moved correctly, if I can figure out, there we go. You see that's Africa, George?
Yep.
And then we go across the Atlantic to South America. Yep. Where what's called the knee of South America fits in to the hole here in Africa. Well, it turns out we have enough laser technology now to be able to measure if Africa today is moving away from South America. And Paul Lohmann argued 40 years ago that if you look at the standard deviation of error of the method, they're always saying, oh, the Atlantic is widening by a centimeter a year. Well, if you actually look at the measurements that's been made, it's not true statistically.
Standing, can you screenshot that those quotes I sent you, or I can read them if that's too difficult?
Yeah, maybe if you could read them, because I was having an issue downloading them. So
yeah, no worries. David, Jordan in the chat spoke about the ratio of parent to daughter elements.
Yes.
I'd like to address that through something that the National Nuclear Security Commission had said. Okay.
Okay, please go ahead.
And then I'll follow it up with another source as well. Okay. The National Nuclear Security Commission says this. I quote: radioactive elements in soils, secondary deposits formed due to the leaching of uranium from minerals during chemical weathering. Uranium is mobile in groundwater, but is readily precipitated by humic acids in soils. It may be found in carbonized plant or animal remains, and may also fill openings in porous soils. Now, the second quote I have is here. It's a paper you can actually download yourself. It's called. It's titled "Migration of Radioisotopes in the Earth's Crust," and it's written by Roger Eckhardt for the Isotope and Nuclear Chemistry Division.
Okay, I'm making notes here. Is that an Australian group or a North American group?
I'm not sure. I'll send it to you via email, David, so you can look at it more closely yourself. But this is what he says. Quote: "Most people are aware that rainfall, as it seeps into the earth, becomes laden with dissolved material or solutes. What they may not realize as fully is that the composition of the solutes can change drastically as the water passes from one geochemical environment to another, causing significant relocation of particular elements in relatively short geologic times."
Yes.
Now, these are studies that defeats that parent-daughter ratio completely because of the leaching problem. Groundwater will leach these elements or these isotopes, and therefore you can't reliably account for the ratio of parent to daughter.
Now let's help those that simply do not want to go back to college chemistry to remember. Here's the water in the glass.
I think it might be
water is called. Say it again.
Microphone. I'm not using. Oh, I apologize.
No, okay. At any rate, water is called the universal solvent. And so what George is talking about is if you deal with groundwater, and I worked for 26 years as a groundwater geologist, so I know exactly what George is saying. If the water goes through a uranium-rich area, the solvent, the universal solvent of water, takes into solution a solute of uranium-rich material, and it begins to move it through the rocks of the time of the Great Flood. There is all over the world a type of uranium deposit that's called a roll front uranium deposit. Professor Dr. Andrew Snelling actually worked for a uranium company at one point. He knows all about this in the Australian context. I studied at Michigan under a guy that taught me about it in the Western U.S. context. This water would move through a log, and the uranium would come out of solution in that log and would form what Bob Gentry called secondary halos. In other words, as it filtered through that log, and where's my pencil? Imagine the pencil to be a log, and the water containing uranium and thorium and polonium is moving through that log. The log serves as a kind of a chamber, if you will, that separates uranium from thorium, from polonium. And so in that log, you can see what is called secondary polonium halos, which are evidence for the Great Flood.
Thank you for that, David. Yeah. Do we take some more questions standing?
Well, I will say this. We just got a $10 super chat from Noble Eagle. Thank you so much.
Well, let me answer Noble's question here. Yes. What is the best short and simple answer to give to someone that believes that dating methods proves an old Earth idea? In light of what we've said today, you can say that there's evidence in minerals, in the very igneous rocks that are being dated, that shows the radioactive decay rate has not been constant with time. And so for some professor to stand up and say, okay, boys and girls, the Earth is 4.5 billion years old. Well, it turns out that the work of Gentry in halos of polonium found in fluorite and mica worldwide. That shows that one of the primary assumptions of radiometric dating is incorrect. The decay rate cannot be shown. Lambda cannot be shown to be constant. And so, again, to go back to the equation here, since the half-life is proportional to the radius, that's objective scientific evidence. What George just said cuts across the second assumption, and that is that how can we know that uranium has not been added or subtracted over the last billion years? There's no way we can know that. And then the third reason, and this is a logical argument, is if uranium is decaying into lead and thorium and so forth down the chain, if potassium is decaying into argon, how can you know the original amount of radioactive potassium? How can you know the original amount of uranium in the rock? Geologists use a technique that's a topic for another day called isochron analysis to try to get around this. But Dr. Steve Austin has shown so clearly regarding the rocks in the Grand Canyon that these methods end up showing inconsistent ages.
The other problem too, David, I think we discussed this, previous presentation on the geology of the moon. We spoke about the short-lived uranium-236 and thorium-230 that are found in stones on the moon. Yes. I mean, that's another problem for them, not for us. So I don't know how Jordan will explain that one away.
Well, here's a question from Standing for Truth. The critics say that isochron dating resolves any assumption relating to the problems associated with the dating methods. Is there validity to this claim? If you're a professional geologist and you have gone to schools like I have of Tennessee and Michigan, schools like Steve Austin's PhD is from the Pennsylvania State University. If you go to these big schools, they will ask you on your PhD oral exam, what resolves these assumptions? And then you're supposed to say, well, isochron dating resolves these assumptions. But the additional work of creation scientists, especially from around 1980 up until now, shows that that's not true. It's what George has called so many times the idea of shooting yourself in the foot. You're standing on this huge argument saying that isochron dating solves all of our problems. And then, George, you end up shooting yourself in the foot, don't you?
Correct, yes.
What about this question? Because I had this one up on the screen earlier. I don't want to miss it.
Okay.
Because our Gotha asked us a little while ago, says, if you date a rock that is too young for the method, will it give you a date in the method's range? If so, how is this not circular?
Okay, let's use an example from the Grand Canyon. From the 1980s on, Dr. Steve Austin, Dr. Andrew Snelling, and others collected rocks from lava flows that go over the edge. Imagine my coffee cup is the edge of the Grand Canyon, so you can see down in the Grand Canyon. There are lava flows that have flowed over and down into the canyon. Well, if you look at the traditional geology of the canyon, this goes back to Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, Permian, and so forth. If you look at what's in the canyon, there's almost no Ordovician. You got Cambrian, you got other things. But if you look at those ages in hundreds of millions of years, and you use different methods to look at those lava flows, you get discordant ages. Like if you use uranium lead, you'll get an age of this. Let's say, and I'm just pulling numbers out of the hat here. let's say you'll get a number of 1 billion years. And then you use rubidium strontium, and then you get an age of 500 million years. And then you say, let's use something else. Let's use potassium argon. And then you get an age of 200 million years. Well, how do you choose between that? It goes back to the power of what Dr. Sarfati has done such a wonderful job in pointing out in his books and on Standing for Truth. It's the power of presuppositions.
Right.
It's the power of your assumptions. If you want evolution to be true, you have to have billions of years. No evolutionist that I've ever confronted in my 50 years of talking about this has ever said, oh, McQueen, it doesn't matter if the Earth is 6,000 years old. We can have evolution. Nobody thinks that in a few thousand years we could go from chemical evolution all the way through what Darwin suspected we'd find leading up to human evolution. You have to have billions of years. And so if you want to use what's called presuppositional apologetics, presuppositional theology, that's where the kicker comes, because evolution is a religious statement. It's not a scientific statement.
Right. That's a great point. That's why I always say time is the hero of the plot for the evolutionists. They need the billions of years to take their single-celled-like ancestor into a whale and a human. So that's a good point, Professor McQueen.
Standing, can I bring another example? I think everyone is aware of Leakey's skull, 1470. Now, 10 years, they did this for 10 years, and they dated all sorts of things, and they got, published dates of, I think, 0.5 million to 230 million years. Now, for anyone that can do quick maths, that's a 46,000% variance. Now, come on. These guys are just picking things to suit their narrative.
Mathematics and statistics, chemistry, every science is an enemy of evolution. Gentlemen, may I take my 5-minute break now, and you drop me from the video, and I will be back. And when I come back, I want to give my 2 cents worth about catastrophic plate tectonics and the idea of accelerated radioactive decay. Is that okay, Standing for Truth?
Absolutely. You've earned yourself a much-deserved break, Professor McQueen.
And George, pick it up and carry the ball for me.
No worries.
It's as if we're playing rugby. I assume you know how to play rugby.
No, I've never played rugby, but I've played Aussie rules and soccer.
Well, good. I've never played rugby either. I was just playing with you. I'll see you guys in 5 minutes.
No worries.
Okay,
Standing.
no worries, Professor McQueen.
Standing.
Yes, Brother George.
If you get an email with the subject knock knock, don't open it. It's probably a door-to-door salesman working from home.
I like that. I wanted to point something out, George. I've heard this argument now a few times from our favorite critic, Gutsick Gibbon. The claim the claim employed in order to argue against the C14 in diamonds, showing that diamonds and the Earth essentially can't be billions of years old. And the claim is that, and I'm curious as to your opinion, the argument, I should say, is that other nuclear material down where the diamonds are can actually recharge the C14. And I want to point out that, as you know, George, this doesn't work at all. This is a rescue device. And this is what's hilarious, George, is the RATE team themselves, okay, who found evidence for accelerated nuclear decay in the rocks themselves. This is observable evidence. The RATE team actually looked into this, and they estimated that you would literally need, George, 13,000 times, okay, 13,000 times more nuclear material in the nearby rocks in order to actually recharge the C14, essentially. And the point is, you would need far too much far too much material to recharge the diamonds. It's unrealistic. It's not feasible, and they just can't explain away the data found in these diamonds. What are your thoughts on that? I mean, I just keep hearing that rescue device over and over again, George.
That's correct, Standing. And who'd want to wear a ring with that much radioactivity coming out of it?
Right,
But this is the thing, right? Dr. Baumgartner and Dr. Safadi in separate emails, and even in his paper in the rate book, states that to account for the. Oh, actually, let's go back. We know that carbon-14 has a half-life of 5,730 years, while uranium has a half-life of 4.5 billion years. Now, this is the problem, right? The carbon-14 is decaying at approximately 800,000 times faster than the uranium can make it. And the other problem is this: even if it was to account for the carbon-14, it would only account for it to, get a load of this, 0.0001% modern carbon. That's out of the range of the AMS method, because they only measure to 3 decimal points. So that 13,000 figure that you mentioned is corroborated by Dr. Safadi and Dr. Baumgartner. I think Dr. Baumgartner said 1 in 10,000, and Dr. Safadi calculated 1 in 13,000th. So yeah, that rescue device fails. It fails miserably.
It fails miserably, and I want to point out, I'm going to try and find it. I have some slides on it, but since I have 1,000 slides, I'm going to find it real quick. All of these rescue devices employed by the evolutionist that wants to hold on to this time that they need for pond scum to people evolution, they've all been looked at, okay? They've all been dealt with in very technical articles as well. So if you want to elaborate on that real quick, George, I want to find this slide so people know where to go. Rebuttals to it.
I was just going to bring another argument which I heard from one evolutionist. I won't mention the name, but I thought it was pretty stupid, to be honest. He suggested that the diamond was not an organic diamond. That is completely irrelevant. C14 is C14. The half-life of C14 is 5,730 years. So whether it's organic or not, it makes no difference. These people sometimes they don't think before they actually reply.
No, they don't think before they reply. And instead of tapping out, they look to these weak rescue devices. So in these slides here, check out the article. Where is it? So right in here, Dr. Sarfati, who we've had on a couple times, he has dealt with these arguments as well. And I find it so fascinating that, Dr. John Baumgartner, they found in the radiocarbon lab, they reported that there was over 10 times. Okay. So this isn't just like a minute amount. They found over 10 times the detection limit when it comes to the diamonds. And it talks about how Dr. Baumgartner repeated this many times in order to come up with the data. And the arguments that they're using, like the ones we just debunked, have been looked at and thoroughly dismantled. And there's articles here on like creation.com where I just find it funny because these critics put forth these arguments as if they haven't been looked at, as if they haven't been dealt with. But here's the thing. They need an answer to kind of save face, right? Because, all this evidence here, carbon-14 in coal, carbon-14 in oil, carbon-14 in fossilized wood, carbon-14 in diamonds. It's not just 1 or 2 lines of evidence. It is a massive number of lines of evidence that corroborate on one conclusion, that the Earth is not billions of years old, okay? And it actually puts a limit on the age of the earth that is consistent with biblical creation. So,
yeah, correct, Standing. The other thing with that rate report, they actually sampled 12 diamonds, and the 55,600 years age is actually an average, okay, an average or a mean, which means there were ages younger than that, and some were older than that. But one of the rescue devices I keep hearing is now they've resorted to, carbon dating is not really accurate over 50,000 years. Yet the AMS people claim that it's theoretically accurate to 75,000 years, and it has a theoretical limit of 95,000 years. So it's just another rescue device to counter the diamond age of 55,600.
well, it's a really weak rescue device because that's the entire point, is there should not be any carbon-14 found in these samples. For example, the oil, the coal, the fossilized wood, the diamonds. That's why the fact that it is being found points to ages of thousands of years, which contradicts the ages of millions and billions of years. That's the entire point. It's circular in their mind. Yeah, go ahead.
Here's the thing, Standing, and they do this often enough. They throw people under the bus. Then they blame the laboratory background contamination. I mean, these guys that work in there are scientists. They're professional scientists. They do this for a living. They regularly measure the background the background contamination levels in the labs, and actually account for that. They actually subtract that amount from the reading. So it's just another example of them throwing their own people under the bus.
That's right.
Okay, gentlemen, I am back.
Good to have you,
David.
Are we ready?
David, I'll introduce you to a new joke.
Yes, please.
A teacher says, if H2O is the formula for water, what is the formula for ice?
Oh, I don't know. I'm frozen.
The student says H2O cubed.
Cubed. That's actually funny. I take notes. This whole idea that you've come up with of rescue devices, that's good. I'll write the joke down also. Let's go ahead and make the transition now to talking about catastrophic plate tectonics and accelerated radioactive decay. I noticed that one of the questions that Jamie Russell wrote was, did Gentry think that they were created in the event of creation in the granite? And this is something that Andrew Snelling and I and a number of people have discussed over the years. That is Gentry's viewpoint, that if you find a granite that is a geologic textural granite, I'm talking about with crystals of quartz as big as my right hand, crystals of orthoclase as big as my left hand, crystals of biotite as big as my head, a huge piece of granite, that you cannot produce that in the lab. Well, it turns out you can't produce something like that in the lab. What they do is they will take silicon dioxide and they'll add some potassium to it, and they'll add some iron and so forth, and then they'll heat that up in a vessel that's a couple of millimeters across, and get a glass that is the chemistry of what's called the bulk rock chemistry of granite. But to answer the question that was asked by Jamie Russell, Gentry did believe that any granite that you found worldwide is an evidence for either the first or the third day of creation. Now, other creation scientists, as I've said, Dr. Andrew Snelling, believe that some of these liquids could have been mobilized during the catastrophic plate tectonics of the Great Flood, and move on from there. So let me introduce my next talk here with one word, and that's the word heat. as we do further research, one area of criticism that the evolutionary community, the geologic community, atmospheric scientists come back to over and over again is explain to me the second day of creation, the waters above, the waters below. Dr. Russ Humphreys has a very elaborate argument about this that is in regard to his work on the starlight problem, the age of starlight. Others have got other ideas about the second day, but whoever's got the idea, as Dr. Larry Vardaman has pointed out, the issue is heat. How do we deal with heat? Well, if you have the movement of plates, and I'll try to move my chart in as close as I can get it here and move it to where we can use it. Let me see if I can point to it. Here you've got a plate being subducted and producing a volcanic terrain on this side of it. Let's imagine this here to be the Pacific Ocean during the Great Flood. And then this is what's ended up being Japan. And so the subduction there, as I understand it, is from the east to the west. If we're talking about California, it's just the reverse, where the subduction there, as you go up through Northern California, up to Alaska and so forth, is from the west to the east. But no matter where you are, this subduction is something that is considered by many geologists to be the crowning glory of 20th century geology. The idea that you have plate tectonics, these plates around the earth that were defined by mid-ocean ridges and then interpreted to be the source of the power to produce the Appalachian Mountains, the Atlas Mountains in Morocco, the Rocky Mountains, and so forth. So when a creationist began talking about the continental separation occurring during the time of the Great Flood, again, the geophysicists said, wait, McQueen, Austin, all you guys that are claiming that this happened within 12 months, what in the world are you going to do with the heat that had to be generated by the movement of these plates and so forth? At this point, it would be good to tell you a story. I called Dr. Larry Vardaman and asked him to give me some background on the RATE project that George has mentioned. And many of you are aware that Dr. Baumgartner created a computer model which helped to explain the movement in the mantle of the earth. But many of you may not know the backstory of Dr. Baumgartner. He worked at one time for Campus Crusade for Christ in Europe, and every time he would go out to talk about the Lord Jesus being our Savior, he would mention things about flood geology and Genesis and so forth. Well, the leadership of Campus Crusade asked him to focus more just on the apologetic of the resurrection of Christ and so forth. But he wanted to study the geology. So he left Campus Crusade and enrolled in a California university for the express purpose to learn how to do what is called computer modeling. George, I would imagine in your career, you have seen a number of engineering models that are done on a computer to estimate stress and Young's modulus and all these different features.
Oh, yeah. I've actually used a few to do structural analysis, but I actually also did part of a computer science degree as well, David. So I've got a good understanding of computer models and those sorts of things. Yeah.
And so let me tell you the brilliant gift that the Holy Spirit gave Dr. Baumgartner when he was doing this research. All the computer models that had been done up until when Dr. Baumgartner did his work. Imagine the Earth. Let me get my model here. Here's my model of the Earth. To honor my friend George, I always try to find Australia on this thing. I know it's somewhere. Where is Australia? Oh, there it is. It's down under. And so all the models that were made prior to Dr. Baumgartner's work emphasized a computer model based on cylinders. And so the cylinder would use that to model the distribution of heat in the Earth. And then behind me, right over my shoulder here, you can see the core, the mantle, and the crust. And so this was the standard model. Well, what Dr. Baumgartner, again, and he gives credit to the Lord Jesus for this, he was sitting around and he said, well, what if it's not a cylinder? What if we model this based on, if I can do a decent diagram here, based on, for example, a pentagon or a hexagon or an octagon. So here's a quick drawing of a pentagon. And it turns out that if you use this cylinder model, your computer model falls apart at the poles, the North Pole and the South Pole. But using Baumgartner's model, it smoothed out the data as you go in the Earth's crust from pole to pole. And he was so well received with this model that he was offered a job at a famous laboratory out west. And when they said to him, we would like you to model the explosion of a nuclear weapon in the atmosphere using your very clever computer model, he said to them a remarkable thing. He said, first, you need to know that I dedicated my PhD dissertation to the Lord Jesus Christ. So I have interest of my own. Why don't you provide me a Cray computer? Let me get a sip of coffee, George. Explain to the audience just how powerful a Cray computer was back in the old days.
Oh, very, very powerful. I believe, I can't remember the number, but it was like 100 or 1,000 times faster and quicker than a normal mainframe computer.
Yeah, exactly. Comparing it to an IBM 360, yeah. I'm showing my age here to be this old, to give you a sense of how important it is for me, not to date rocks, but to date redheads. Here's what my wife and I look like during our first year of marriage. There she is with our Jeep and so forth. And in a month, Ms. McQueen's going to come and help me with the talk. By the way, that's what I look like in the old days, George. That's before we had 4 teenagers. This is what 4 teenagers do to you as you raise them. We'll go to Ms. McQueen another day. She has a nickname. It's based on a British comedy, She Who Must Be Obeyed. So we'll talk about her another day. Let's go back to the physics of this. So Baumgartner said, I will come to your lab and work there, but let's cut a deal. You give me a dedicated Cray computer and I'll do your work up until lunchtime. And then the other part of the day, I'll work on what I want to work on. And so Baumgartner then used his time on the Cray computer. In the 1980s, he published this. The first International Conference on Creationism was 1986, and then the second and the third have gone on. Well, in probably the second one, he actually brought his model to the International Conference on Creationism, and this is where he introduced the idea of catastrophic plate tectonics, using his model of how, and let me go to my chart behind me again here, how the second layer, the Earth's mantle, moves and behaves in a computer model. So now, where do we stand in the 21st century? We stand with the idea that continental separation, plate tectonics, if you will, occurred very rapidly. And Baumgartner's model provides us with a computer model of how this could happen during a year-long worldwide flood. Now, keep in mind that creationists are not saying that every separation had to happen by the time the ark landed on Ararat. If you notice a map of the Middle East in between Africa and Saudi, there's a gulf there.
Yep.
And if you follow that down, it's obvious that it's separated with time. Maybe that's separated 100 years after the flood. I don't know. But there was tectonic activity all around the world that maybe have lasted in what I call the post-flood residual catastrophe time of my own model of the Great Flood. So you've got this activity going on. And so catastrophic plate tectonics, that idea geologically led to the concept that we want to also cover, and that's the idea of accelerated radioactive decay. One of the questions that have been asked for decades is, how in the world could God have orchestrated the breakup of the fountains of the Great Deep and the beginning of the Great Flood in Noah's day? Well, one answer to that is that perhaps radioactive decay during the creation week and in those, remember that Methuselah lived 969 years. He probably died the year of the flood. If he hadn't died, there would have been 9 people on board the ark instead of 8, because he was a righteous man. So you got at least 1,000 years between Adam and the flood. You got more than that if you add up the numbers. But the point is, for rounding purposes, what if a radioactive decay rate was more rapid at creation and then during Methuselah's life, and that built up the power and the energy to break up the one world continent into the continents that we see, if we can get the world right side up. There we go. Australia right there in the middle of the world, as it should be. And then the minor continents of Africa and Asia and North America, South America come in to the picture. That is an overview of both catastrophic plate tectonics and also the idea of accelerated radioactive decay. One of the words that Bob Gentry used in the 70s that I did not know when he first started using it, he always talked about the word singularity, that the creation was a singularity. And the way he would write this up in his technical papers, it's almost unbelievable that he was able to get this through the critics. Let me read to you the last paragraph from this paper that he did in the 70s about the whole idea of lambda and the idea that you cannot know that the radioactive decay rate has remained constant. This is his last paragraph. The X-ray data in figure 3 is unambiguous and should remove any doubt that previously reported lead 206, lead 207 mass ratios actually are lead isotope ratios. They in fact present a new type of lead derived specifically from polonium alpha decay. In summary, the combined results of ring structure studies, which we talked about in the first hour, mass spec electron-induced X-ray fluorescence present a compelling case for the independent existence of polonium halos. The critics of Gentry's work, like Dalrymple, for example, when he presented evidence at the Arkansas creation evolution trial in the 80s, he said, oh, this is just creation's tiny mystery. It's no big deal to a geochronologist like me. All of this polonium is secondary. It's secondary after the decay of uranium. Well, this paper in Science shows this: the independent existence of polonium halos. The question, this is how he ends it. I can't believe he got this published. The question is, can they be explained by presently accepted cosmological and geological concepts relating to the origin and development of the Earth? That's remarkable. It's in Science magazine. The idea of a singularity. That should generate some questions standing for truth. Okay, let's go on to a discussion now of this.
Yeah,
George, react.
Yeah, George, actually, George, if I could start this off real quick, just because Professor McQueen was saying a couple things that I wanted to comment on before I forget. And what you were saying about the CPT model, I think, is so good, Professor McQueen, because I've heard Dr. Snelling explain it too, where meters per second movement of the plates, they can actually explain the uplifting of the mountains. And I've seen Snelling use an example of, say, two cars coming at each other at 100 kilometers an hour, which would result in rapid buckling of the rock strata to actually push up the mountains. While the snail pace movements of the plates, right, present geologic processes that we observe could not explain the uplifting of the mountains, because you wouldn't get that buckling if it's just like two cars going at each other at 20 kilometers an hour won't result in the necessary buckling that we see.
And your comment about Dr. Snelling is so important. He and I have been friends for decades now, and we agreed long ago that I'm more handsome than he is, but he is smarter than I am. And so I enjoy reading what Dr. Snelling does. Good point.
I think you're both highly intelligent, brilliant men. I'll say that.
Well, call our wives. I'll put the cell phone number up here in a minute.
Go ahead, George. I apologize for taking over there.
I just thought it was funny. I read a comment on the chat that said young Earth creationists hate index fossils. Hello, we love index fossils. I'll just cite the coelacanth and circular reasoning. That's all the index fossils are, circular reasoning.
I see. I see Ian Chen's question here about how a guy like me, a geologist, should hate index fossils. I need to bring that up more clearly. And I'll use an example that I've used before, which is my favorite example, about the trilobite being an index fossil for the Cambrian. There was a professor in England in the 1800s who was the Reverend Professor Adam Sedgwick. He was a pastor on the weekends, and then he taught geology during the week. And so Sedgwick would always take his class to Wales in south central England, and he would show them a sandstone that was that included a green mineral called glauconite, and by the way, it also had a trilobite in it. And so I can just see the man going to the board and writing on the board like I have in my teaching days. Okay, next Saturday, we're going to Wales to look at a sandstone that's got the green glauconite in it and trilobites. So we got tired of that. And so the place that they would go is the place where the ancient Celtic Cambry tribe was found. And so he then said, we'll just call these Cambrian rocks. And so he'd write on the board, next Saturday, we're going to see the Cambrian rocks. Now, here's a creationist that is using this word just as a geographic word. Well, George, you and I have talked before about what happened in the 1800s. What's the phrase? the sun never sat on what empire?
Oh, you got me there. I don't know.
The
On
sun
the
never sat on
The English
on the
Empire, the British Empire.
British Empire. And so all of these students of Sedgwick went to India and Russia and America. And sure enough, when they were walking in my home state of Tennessee, and they would find a shale that's now called the Rome Shale that has this green mineral in it and trilobites, what would they do? They would say, oh, Sedgwick called this Cambrian. So that's the idea of an index fossil. It has nothing to do with being something that young Earth creationists hate. I embrace it.
David, I believe I've seen a photograph of a trilobite with a foot imprint over the top of it.
Yeah, that's a photograph I too have seen. But let's go on to other questions. Standing for Truth, what do you have as another question we can cover?
Well, I guess you just covered this one, Professor McQueen, about the index fossils. And therefore, I had a question earlier that the chat's been pretty lively. I don't know if, here we go.
I've got a couple if you can't find them, Standing.
Okay.
Yeah, I've got this one.
This is a good one. Redeemed through the blood of Christ. Let's see what he says. What is your response to Talk Origins claiming that creationists ignore the vast majority of radiometric dates showing consistent results? Well, perhaps I should be invited in the future to this group called Talk Origins, because I don't even know how to find them on the internet. But if I were to find them and they would make this claim, once my laughter died down, I would answer it this way. Okay, gentlemen, show me the consistent results of radiometric dates in the Southern Appalachian Mountains, where I was trained as a geologist at the University of Tennessee. Well, they'd probably come and say, well, McQueen, don't you know that paper that Helmuth Weedo and Bob Lawrence and Lynn Harris pointed out to you when you were working for them for the United States Geological Survey about how you can find, and let's see what I can use as an example here. As you go through the rock record, I hope you can see the pink layers and the green layers there.
Yep.
Let's imagine, George, that those pink layers are volcanic ash. So let me tear out a page and go down to the bottom of the pile, which would be the green Cambrian rocks. And let me insert a thin layer of volcanic ash. If I had my Play-Doh, I could show it more easily, but I hope you can see it there. Here you got a thin layer of volcanic ash in that Cambrian rock. My evolutionary geologist buddies, well, actually mentors, would point out to me, oh, McQueen, we can measure this date, and that shows that it's Cambrian or Ordovician. And then as we go through up the rock record, we can find other volcanic layers. And for 40 years, people have argued with me, or in that case, 45 years, that these kind of dates show consistent results. Well, the work of Steve Austin in the Grand Canyon and a number of other people worldwide in Andrew Snelling's big 2-volume book, there are other examples, they are not consistent results. So my answer, and honest, faithful, and true anticipate my answer there simply are no consistent results unless, now you got to hear the unless. My bosses, one of which was a Lutheran leader in a Lutheran church, he wanted God to use evolution to create all that we see. He wanted to keep in good stead with the fellow geologists in the American Association of Petroleum Geologists. So he had to speak the talk. He had to talk the talk. He had to walk the walk. Cambrian, 500 million years old. Ordovician dawn, and so forth. The dinosaurs 200 million to 100. It doesn't say that. And so if your presuppositions of science are based not on truth, but on a religious idea of evolution, then you're going to claim that these ash layers produce consistent results. They actually do not.
Now, David, you come from an economic geology background. One of the questions that came up was what geological processes form the noble metals, that is gold and silver?
Okay. There are two times in Earth history where we find this. We find it gold, silver, copper, lead, zinc, all kinds of stuff were created during the creation week. And so I'll use gold and AG here during creation week. And then during the time of the flood, and let's say the second part of the flood, 6 months in, you've also got gold and silver deposits created. I'm sorry, not created, but formed. So here are two places where these noble metals come in. How do we know that there was gold that God put in the Garden of Eden? We know that because it says, as it talks about Adam and Eve and their life in the garden, that they, and also on in their descendants, had access to three things. They had access to gold, what's called onyx, and then a compound called bdellium. We're not going to talk about bdellium. Let's go with simply onyx, which is a type of quartz, and gold. So we know that Adam and Eve could walk to the rivers there in Eden, and as they were walking around, I can imagine, having been married almost 50 years, that Eve turned to Adam and said, "Sweetheart, the honeymoon's over, man. We need a table. We need some bowls. We need something to eat out of." And so he noticed this shiny, malleable metal. And as God walked with him, he said, "Why don't you pick that up and hammer it out?" And it's malleable. And so I imagine that Eve had golden bowls that she could eat her fruit in and so forth. And so that gold must have been created in, I would imagine, granites from the time of creation. And then as the third day of creation hit, you have the first great flood, the flood of the creation week, where the waters went off of the land as it rose, and that eroded some placer gold. So that's where it comes from in the creation week. Now, where gold and silver deposits come in the time of the great flood, let me switch gears to silver. Silver goes into solution in the floodwaters. It hits and George, we've talked about this so much, you've got this memorized. What are our, we got temperature, we've got pH, and then what are the last two?
EH and pressure.
EH and pressure. We got these four physical chemical parameters that vary all over the earth and in the sediment that's being laid down. And so if you go to an area in Germany that's been studied for 2,000 years probably, you find at the surface of the ground iron-rich rocks that in German are called Eisenhut, or an iron hat. And if you dig down underneath that, as the descendants of Japheth did, you find a type of deposit that contains copper, lead, zinc, traces of silver, and they would have had access to that in the time after the flood. Your comments about that, George?
No. Look, I've learned a fair bit that I didn't know about some of the things we've discussed today. Standing, do you want me to ask another question, or have you got one?
No, George, you can ask the next question if you'd like.
I'm not sure if we covered this. How can we explain the distribution of rare earth elements and radiometric isotopes in the specific areas associated with what we would say was flood activity? I think it sort of expands on what I said earlier about 90% of the radioactive elements being found on dry land mass. And
yeah, that's part of it. Now,
yeah,
the question is a question that requires additional research. In Standing for Truth, we have the same attitude that Dr. Morris introduced me to when I worked for ICR in the mid-'80s. You work for the Institute for Creation Research, not the Institute for Creation Answers. So the distribution of rare earth elements is an extremely complicated one. I had the opportunity in the summer, the North American summer of 2018 and also 2019, to go south of the equator to the old country of Rhodesia or Zimbabwe. And I have an ongoing research project where I'm looking for pleochroic halos in the granites of Zimbabwe. And I've collected granites and found some biotides. Well, in talking to the geologist at the University of Zimbabwe, there's a tremendous mining interest, a lot of it coming from China, in the rare earth elements. Why? Because you cannot make a cell phone without the rare earth elements. And so there's a tremendous demand economically for where these rare earth elements are found. Now, I must admit, even though I've studied extensively the distribution of cobalt in the United States, I did a project looking for diamonds in the Appalachian Mountains. So I've done very specific things. I must admit, I haven't done research and can't tell you which particular sedimentary rocks in the Appalachians or in the Morocco mountains of northern Africa, northwest Africa. I don't know the distribution there. But remember that one of the things that George and me and Standing for Truth want to come out of these discussions are research topics for those of you that are in your 20s and 30s and 40s that have the time and the strength to go to the Appalachian Mountains, to go to Morocco and Northwest Africa once COVID passes and we can travel internationally. Do this research yourself.
Okay, well, we're getting on close.
Go ahead, George.
I was going to say we're getting on to close to 2 hours. I've got one question, and then probably I'll finish off with a joke, and Standing can have the rest of the time.
Oh, that's a good idea. Go ahead.
All right. A question for David Mcqueen. What are some of the best scientific lines of evidence that limits the age of the Earth? I mean, I can start it off with saying C14 we discussed, erosion rates, soft tissue in fossils, and you can expand on that if you like.
Okay, let me use one of my favorite arguments, and this is one that Dr. John Morris, Henry Morris's son, and I worked together at ICR. He has a degree from the university in engineering geology. And so one of the arguments that a lot of people don't use, that they should use, is when you go through the Appalachian Mountains and the Rocky Mountains, you find rock layers that are folded like I'm folding this piece of paper. And so if the rock layer is folded up like this, it's called an anticline. If it's folded like this, it's called a syncline. Well, the evolutionary argument has said for years, if you take a rigid object like this glass and you apply a small amount of pressure, well, glass is not a good example because it's essentially a cooled liquid. Let's use a limestone that would be rigid like this. The evolutionary argument that I was taught in the 70s, if you apply a small amount of pressure over millions of years, you can bend that. Well, George, you're an engineer. Would you bend it or would you crack it?
It would definitely crack.
It would definitely crack. And so the fact that you find synclines and anticlines on every continent on Earth, and these are folded rocks that have fossils in them, dating from the time of the flood, it shows that these rocks were the consistency of modeling clay, Play-Doh, very soft, to allow them to bend. Because you can't, and you can go through the rock mechanics, the physics of it, the shear stresses. You can't take a rigid object and bend it like that without breaking it. So that's one example to add to what you've pointed out, the carbon-14 in diamonds and other arguments that are really very impressive.
Yeah, we also showed the shale caprock layers above the oil reserves as another piece of evidence where they're folded and bent and there's no crack. If there were cracking, the oil would have leaked out. So that's another piece of evidence, yeah.
Yeah, it's a very good evidence. To compete with George standing for truth, I want to tell my joke first, and he can say his joke second. In Australia, do you have a tool that's called a post hole digger? You know what I'm talking about?
Yes, I've used one.
Do you know what's wonderful about that profession, George? It's the only profession that you start at the top and you work down. And then by the time you're finished with the post hole digger, you've got a PhD, post hole digger.
Actually, George, if I could, just to add one thing before we end it, just to really complete this, based on what Professor McQueen was saying. I always like to bring this up because everything being said is such amazing confirmation of a young Earth and a flood, of course. And the critics will oftentimes say that creationists don't make testable predictions. Well, in fact, Dr. Baumgartner made the prediction based on catastrophic plate tectonics that if plates are actually being pushed down, they would not have had time to melt yet. Okay, so what they discovered after he made this prediction through seismic tomography, when that new form of science came about, and Professor McQueen, you're probably aware of this, they discovered massive slabs of cold rock at the base of the mantle, which means they've only been pushed down there recently because they have not melted. Yeah. And I find that fascinating because that is not only a confirmed prediction based on the CPT model, but it's also confirmation of a young Earth, because if this was due to uniformitarian processes, those slabs of rock that are cool would have melted, or at least warmed up to the material around them.
And again, we can go back to this chart here that shows subduction and the movement of that rock body down, and how fascinating that Baumgartner was able to predict that there should be cold masses. Now we're talking about a volume of rock the size of Queensland in Australia, or the size of British Columbia in Canada, or Arizona in America. Something that size being down in the mantle. It's a remarkable prediction. Good point.
I mean, yeah. Okay, George, I apologize. The floor is yours, brother, for your your job.
No worries, Standing. I actually read a recent article where they actually confirmed that in the plate subduction plate under China. They found the same discrepancy with the cold plates.
Right.
So
Now,
in the future, yes.
Oh, David, I was gonna tell you this is a real true story, right?
Okay.
There are some contractors building a skyscraper, okay?
Yes.
And the engineer, being a smart engineer, runs up to these contractors, says, "Stop, stop, stop!" And they go, "Why?" He goes. The engineer says to them, "You've got the plans upside down. They were digging a hole into the ground."
That's so funny. The you'll notice the hoodie I have on is a local high school here called the Mangum Dragons that I'm a substitute teacher at. In March, we'll have to do a whole section on historical evidence for knights in shining armor slaying dragons to rescue damsels in distress, like St. George. I guess you've heard that story, haven't you, Standing?
Yes. Yeah.
The Soviet province of Georgia, many people don't know, is named for that historical event. It actually happened in North Africa, but in the old Soviet Union, they didn't care about the truth of things. They'd move mountains around to fall into the communist viewpoint. Trying to make George laugh about that, but he's not laughing.
No, Joe, I was going to tell you one, David.
Please.
One tectonic plate bumped into another and said, "Oops, sorry, my fault."
My fault. How clever. That's
you just make that up, George. That's good.
That reminds me of a university class that was offered that dealt with earthquakes and volcanoes. It was called Shake and Bake.
You guys are good.
I'll lift my coffee cup and say goodbye to you, and we'll pick this discussion up next time.
Cheers.
Good on you, David. God bless you.
God bless you, Professor McQueen. Great show. Great job. This was awesome.
Thank you, sir. Next time.
Okay. God bless. God bless. We'll talk soon. So we'll let Professor McQueen get on out of here, and we will end the show, George. This was a lot of. I'm going to re-listen to this one because so much good information. 2 hours have flown by. To think just 2 hours of nonstop information. Yet, George, yet another irrefutable video discussion interview. I mean, it's 2021. It's an amazing time to be a young Earth creationist, and I want to say. The fun's just beginning because tomorrow, George and I will be here with Mike Ord discussing the flood. We're going to have a Q&A. We're going to be here for a couple hours, and it's going to be, I'm pumped. So,
Standing, Jamie Russell has got a lot of good things to say about, he seems to be on the ball. He knows his stuff.
He does. Jamie, we got to have you on one day, brother. Jamie's always got good comments. He's always got good questions. So, this has been great. God bless everybody in the chat. I hope you guys had some fun. I know I had some fun. George, as always, some great jokes. And any other reminders? Next week, Ken Hovind will be debating Jordan, who was in the chat. I really like that we got into the dating methods, the evidence for accelerated nuclear decay, and solutions to the so-called heat problem. But George, I'll say this. Isn't it funny how they ignore all these numbers of all these lines of evidence suggesting that decay rates were sped up? Okay, this is evidence directly in the rocks. But they don't want to rebut that evidence, right? Gutsy Gibbon is notorious for this. They don't want to rebut the testable predictions. They just want to bring up the heat problem, even though we have 20 different solutions for the heat problem. Yeah, I find it, all you can do is laugh. Isn't that right, George?
Yeah, well, we discussed that at length, I think, when we addressed what was it? I think it was Scott Devlin. Scott Devlin from CMI gave us a lot of good material to present to debunk Erica's heat problem. But you're right, Standing. They go to the same talking points over and over again, even though we've answered them over and over again.
Mm-hmm.
And I think it'll continue. Nothing will change.
No. Well, I mean, they're not going to tap out and repent and suddenly believe the Bible, right? Of course not. So, no. Okay, this has been a great show. We just hit the 2-hour mark, George. So I know what time it is for you. You've earned yourself a coffee, some breakfast, some relaxation. So tomorrow, brother, you and me will be here with Mike Ord at 4:00 EST. Okay, everybody. George, do you want to do the honors of giving those final words?
Well, thank you for joining us, and we'd like to say SFT is out.